Good morning, grade 12 learners. Good morning, teachers. My name is Mohapi, and I'm working as a subject advisor for mathematics here in Mutao District. So today we've got a very, very interesting topic that we're going to deal with, and the topic is basically Euclidean geometry. Euclidean geometry, and as you know, Euclidean geometry is that topic that is a bit challenging to most of our learners. And the sad part is that this Euclidean geometry is part of paper 2. And out of paper 2, out of 150 marks from paper 2, this Euclidean geometry is going to take plus or minus 50 marks. So it is very much important that we really do our best in this topic. We cannot afford to make any mistakes at the moment. We need to stay focused and work hard on this topic. Challenging as it is, but we believe through practice, we'll be able to master this topic, and we'll be able to come up with at least 30 marks out of 50 marks based on this topic only. Okay, right? Remember today, my task is simple one, to try and take you through the bookwork. Remember, Euclidean geometry, it has got the bookwork. Basically, in bookwork in Euclidean geometry, we are referring to the proof of the theorems. Bookwork in Euclidean geometry refers to the proof of theorems. So I will take you through the proof of the two theorems in grade 12, namely the semi-proportionality theorem as well as the similarity theorem. Are you all ready now? Thank you. Let's start there. The first theorem in grade 12, remember, is the one that states a line drawn parallel to one side of a triangle. A line Thank you. A line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. That is the theorem. Let's analyze the theorem. And remember, when you analyze the theorem, we must be able to identify the required to prove part as well as the given part. A line drawn parallel to one side of a triangle. As you can see here, we're talking of a triangle. We are talking of a triangle. So let's draw that triangle. Let's say we are given triangle ABC. Let's draw. We've got a triangle there. So let's name it triangle ABC. A line drawn parallel to one side of a triangle. In other words, there must be a line, and that line must be drawn parallel to one side of a triangle. Let's mark off here. Let's say we've got point D there, and then we also have E there, and then we draw DE such that DE must be parallel to BC. We've got a line parallel to one side of a triangle. That line in this case is DE, and DE is parallel to BC. Remember, originally we had triangle ABC. So triangle ABC has got three sides, namely AB, BC, and AC. So the theorem states a line drawn parallel to one side of a triangle. So that line in this case it will be DE, which is drawn parallel to BC. The theorem states that line cuts the other two sides in the same proportion. It means this will then be the required to prove part. The required to prove part. What is the required to prove part? That line DE divides AB and AC in the same proportion. In other words, we've got to prove that AD over DB must be equals to AE over EC. That is the required to prove part. Let me start again. A line drawn parallel to one side of a triangle. We said we've got triangle ABC, and the line that is drawn is line DE, such that DE is parallel to BC. So the theorem states that line, which is parallel to one side of a triangle, it will divide the other two sides in the same proportion. So it means, you see, this AD, this point D, it cuts AB into AD and DB. The very same thing applies to point E, which cuts side AC in AE and AC. So this is the theorem. This is what we want to prove. We want to prove that AD over DB is equals to AE over AC. It's going to be very much interesting. We've got to relax and try to apply our previous theorems properly. The most important thing, we've got parallel lines here. So before we can start with the proof of the theorem, let's do some construction. Let's do some construction. The construction part. Thank you. In our construction, we're going to draw, height, let's name it K, relative to base AD, relative to base AD. Let me draw it so I can have a look at it. Let me draw it. Here is, we are going to draw height K relative to base AD. Here is base AD. Now I'm going to draw height K. Because its height, you indicate is 90 degrees there, therefore this height is K. Now again, we are also going to draw height H relative to base AE. Let me draw height H so such that AE becomes the base. There we go. Now AE is the base because it's a height 90 degrees, and this one we denote by the letter H. Thank you. And then let's join DC and BE so that we should have areas between two triangles. Let's join BE and DC, then we can talk of the areas between the areas of triangles which lie between two parallel lines. Let's join with the aid of a ruler. You join. You join. Now we've got our triangle, we've got all our constructions clearly indicated. Now let's start with the proof. Remember the key thing here, the key thing when proving this theorem, is to know the area of a triangle. From junior grades, you knew that the formula that we use, you were taught that the formula that we use for determining the area of a triangle is half base multiplied by height. Half base multiplied by height. Then let's carry on with that formula then. Proof. Now we prove. Let's determine the area of triangle ADE and the area of triangle BDE. Please take note. I have chosen triangle ADE such that AD becomes the base, and we also have got triangle BDE such that BD will be on the baseline. So the height for both triangles will be K. Then let's prove area of triangle ADE. We are going to divide that by area of triangle BDE. Thank you. Let's work it out. This is equals to area of triangle ADE. Remember, area of a triangle half base multiplied by height. So look at triangle ADE such that AD becomes our base. So the formula will then be half base. We choose AD as a base. So half AD times height. Height in this case will then be K. We divide by area of triangle BDE. So if look at triangle BDE, we choose BD as a base. So the area will then be half base. Our base is BD height. Height will then still be K because it's on that baseline, the line in which the base is found. So you try and simplify this. If you simplify this further, then you'll find that half will cancel half, half into half once, k into k once. So ultimately we are only left with what? We are only left with AD over BD. AD over DB. Thank you. In other words, what we have done right now is that the area of triangle ADE, you divide by area of triangle BDE, it gives you AD over BD. AD over BD. You remember why? Because half will cancel half, they've got the same height. They've got the same height, which is K. So K will cancel K, then ultimately we are only left with AD over BD. Let's carry on again. Let's come to this triangle now. The very same triangle ADE. The very same triangle ADE, but now we'll be comparing its height relative to triangle DEC. Thank you. Let's start. Let's carry on. Area of triangle ADE. You divide by area of triangle DEC. Let's check. Remember the formula that we use to calculate the area of a triangle? The formula is half base multiplied by height. The formula for calculating the area of a triangle, half base multiplied by height. Check the diagram. Triangle ADE. Now we choose our base as AE. AE is going to be our base. So the area of triangle ADE will be half base. Our base is AE times by height. Height in this case will then be H, because H is the one that is perpendicular to AE. Then let's write down the substitution. Area of triangle ADE, like I indicated, will be half. Our base will then be AE multiplied by our height is H. Then you divide by, check the area of triangle DEC. Triangle DEC. We choose base. Our base, we are going to choose EC as our base. So if EC is our base, what is the line perpendicular to the baseline? H. So it will then be half EC times H. Like we did with the previous one, we simplify that further. Half into half once, H into H once. Therefore, we are left with AE over AC. We are left with AE over AC. What is special here is that there are things that are a bit common. Check. We have been talking about the area of triangle ADE. Even here, it's still area of triangle ADE. So, something that is what is common. Area of triangle ADE is common in both cases. But check area of triangle BDE and area of triangle DEC. Remember the two triangles, triangle DEC and triangle DEC and triangle BDE. They are between the parallel lines. So if they are between the parallel lines, it means their height can be the same. And you can just decide to choose a common base. So what does that mean? It therefore means that area of triangle BDE, area of triangle BDE is equals to area of triangle DEC. Learners, I'm talking about, look, we've got DE, which this side DE, which is parallel to BC. So the two triangles, they are between the parallel lines. So if the two triangles are between the parallel lines, they can have the same height. And depending, if we can choose DE as a base for both triangles. Check triangle BDE. You can choose DE as a base. Check triangle DEC. You can choose DE as a base. So they can have the same base. Because they are between parallel lines, the height will also be the same. So they've got the same base and same height. That's why we say the area should be the same. Area is equals to half base multiplied by height. So now we are having two triangles in which The two triangles have got the same base and the same height. That's how we conclude that their areas are the same. That's why here I said area of triangle BDE is equals to area of triangle DEC. The reason would be the two triangles have got the same base and height. Same base and height. Because they lie between parallel lines. They've got the same base and same height. Thank you. Let's go back to our ratio.